Institute for having me and organizing this. I think it's a really important function that Metcalf is playing, and I'm glad to see you all here. So I'm going to give a talk through really some basics of sea level rise projections, and look in the near term, look in the far term, and share some tools which I hope might be useful for you as well in your reporting. The big question, really, the main question at least science journalists focus on when they talk about sea level rise is how much will sea level rise, how fast, and will we need devices like this tide gauge that you can see in the foreground, or will we need ones that look more like that? The answer is actually both. We're going to get that high. It's a question of when, not whether. Now this is a picture of near the Thwaites Glacier in West Antarctica. You might have heard West Antarctica in the news recently. Antarctica is the biggest source of ice in the planet. There are about 200 feet worth of sea level rise in Antarctica. Now, most of that is locked up in a way where it can't possibly contribute to sea level rise for a very, very long time. But in West Antarctica, there's about 10 to 13 feet of sea level rise potential that could go much more quickly. And a paper actually just came out this Monday. There's been a lot of attention on the Thwaites Glacier because it's kind of the cork in the mouth of the bottle. And there's been there's been a feeling in the glaciological community that if you unplug that cork, the rest of West Antarctic ice would slide into the sea. The study on Monday confirmed that intuition with a rigorous modeling study. So I'd say West Antarctica is like a bomb with a long fuse, and we're not quite sure whether the fuse is lit yet or not. But we're going to be measuring, if it goes off, we're going to be measuring sea level rise from West Antarctica at a rate of inches per century until a transition after which it may be feet per decade. It's kind of a wicked problem. Some people think it's already been destabilized. Some scientists think that. Others think that it might be destabilized. There are a couple studies now suggesting that another 50 years or so of continuing decay at its current rates would be enough to light that fuse irreversibly. I will say, more encouragingly, that we actually don't even know that climate change is driving the current decay of Thwaites. There are good reasons to suspect that it is, but it's not a straightforward story. It's not surface warming. The melt is being driven from below, from warm ocean water that's being pulled up from the very bottom of the ocean through changes in circulation. Those changes in circulation seem to be linked to changes in wind patterns around Antarctica, which might in turn have a climate link, or an ozone hole link, or both. But it's really hard to understand just what's going on with Antarctica because it is so far away, so difficult to work in. We have such a short-term record, and the science is just hard. So Antarctica is the biggest ingredient in future sea level rise. And just to underscore that a little bit more, this is an image of what Antarctica would look like without the ice. And the interesting thing to see is that a lot of the bedrock is below sea level. So many of the great ice sheets are grounded below sea level. That's what leads to that instability. If you unplug the cork, ocean water is going to be running downhill. So, and melting the ice sheets from beneath and destabilizing them. And those are the bluish areas. And that's the neighborhood, that's the Amundsen Sea sector where the Thwaites Glacier is. Then there's Greenland. There are about 20 feet of sea level rise potential in Greenland, and we've seen a real acceleration of ice loss rates from Greenland, as this slide illustrates. Another source, which has been relatively more important over the last century, kind of Greenland and Antarctica are the monsters in the closet looking forward, but the last century, there's been a significant contribution from warming ocean water and its thermal expansion as it warms. The cap on the potential for warming oceans is about 3 feet per century of sea level rise at the fastest warming rates. So a much lower potential than the ice sheets. And then there are melting glaciers, which have also contributed this century, but there's probably just another 3 feet total globally of sea level rise left in the glaciers that remain on the planet. When we project sea level rise forward, one thing we can do is use evidence, fossil evidence of historic sea level rise in geologic time. So this is an ancient coral reef, and some of the projections I'm about to share with you and some of the maps have their foundation in a methodology that kind of marries models that model what might happen going forward, but line those models up with historic records that relate global temperature to global sea level in past warm periods. For the last 3 million years or so, the Earth has been going through cold and warm periods, glacials and interglacials. The cold periods are generally much longer than the warm periods. We happen to be living in the most stable warm period we've ever known of right now. And so we can look at those past warm periods and ask how warm was the planet and how high was sea level. And if we do that analysis, we find that on slightly warmer planets, this is from a review published in Science this summer, sea levels were much, much higher than they are today. The headline of this paper was probably 20 feet, 2 degrees Celsius of warming. Our target in global negotiations would translate to 20 feet of sea level rise at or near equilibrium. Now, I'm not telling you anything about when that happens, how quickly that happens, and of course that's the huge question for us. It's much more, if I dumped a pile of ice in this room, it would be easy to say how much of it will melt, all of it. So we have a really good sense, a better sense of how much the sea level will rise, but it's much harder to say how quickly it will melt. We'll all have different opinions and it will depend on the details. So now I'm going to show you some maps we've made out of different projections from what I would call locked-in sea level rise. We can draw a relationship between the amount of carbon we put in the atmosphere to how much it is likely to warm. That warming, because the carbon has such a long lifetime in the atmosphere, will endure for hundreds and thousands of years. So we can draw a line from the cumulative amount of carbon we put in the atmosphere to how much sea level rise we can eventually expect. Not, to be very clear, not going to affect us today or tomorrow, but it is the legacy that we're very clearly leaving in the longer term. And we have a choice between different legacies over the next few decades because the consequences of different carbon pathways are very different. Unless you live in Boston. Some places, it doesn't matter very much. Some places are low enough that even under the best case scenario on the right, the right-hand panel here represents peaking global carbon emissions within 5 years from today. The panel on the left represents business as usual. Boston doesn't look great under either. These maps are based on a study colleagues and I published in the Proceedings of National Academy of Sciences just a few weeks ago and released these maps online, I should say, at choices.climatecentral.org. So we've got these for the whole US, type in any city. We have a few photorealistic images of Partner developed based on our water levels. And so this is an impressionistic look at the Back Bay of Boston under the better scenario and the more drastic scenario to give a kind of concrete sense of what those maps mean. And we can take a little tour around the US very briefly. Here is Norfolk, Hampton Roads. Okay, you can maybe imagine a viable future under extreme carbon cuts. Maybe. Hard, but possible. You can't imagine it under business as usual. San Francisco is luckier. It's got a lot of hills, but there's still a significant difference between scenarios. Here's the embargoed part of this talk. As of this coming Monday, we will expand that map and analysis globally and put it in a reference frame of degrees warming that link to the upcoming talks in Paris, global climate talks. So you can see the Chinese have a big stake here. This is the world's largest megacity and its future under business as usual or meeting our target that we've established globally, which I think both of these actually underestimate the risk to Shanghai because of the quality of elevation data is less globally than in the US. With that, we will be releasing a global Google Earth layers that you can get in and develop scenes in 3D cities that will be downloaded for making video to get that tangible sense. Here's a couple looks at London. So now I'm going to shift back into the present for my last few slides, and actually probably where we should dwell in questions and answers, except we're very focused on this longer-term mitigation picture right now with Paris climate talks coming up. We have a tool called Risk Finder, Surging Seas Risk Finder, that offers a lot of analysis and detail on near-term sea level risks in the coming few decades. And as the next speaker will tell you, the game is not so much how much sea level will rise over the next few decades, but how sea level rise is affecting floods. So the chart here, which is part of our tool, isn't a sea level rise projection by itself. It is a projection of the annual risk of flooding above 4 feet. This one happens to be a tide gauge near Boston, and we chose 4 feet. We could choose any water level you're interested in this tool and get a different graph. But the pattern I want to point out is a pattern that we see reflected around the country at almost all the tide gauges we've analyzed, which is that with most sea level rise projections, there is a sharp transition for any flood level from a very low annual probability, here, less than 5% annual chance of flooding above 4 feet around Boston today. Within a few decades, it's flooding at that level every year. So there are a lot of places where in the light you can buy a house and maybe it's never flooded before, or maybe it's flooded once, and by the end of the mortgage cycle, it could be flooding every other year or every year at that level. And we're entering that phase for some parts of the country. And there's a lot you can play around with in here for lots of different projections. I'm not going to get into the detail, but there's documentation on the site. The site also has maps. Here's Boston. Boston has that nice red levee up there, a dam, which is protecting a lot of the city up to certain water levels, which is why most of the blue here is hatched instead of solid. That indicates protection by levees or ridges. And you can play with different layers. We overlay this with population density in Boston or property value. And a separate unit allows you to go in and understand the impacts. How much stuff is exposed, right? What's the human story here besides the map? How many schools, airports, road miles, EPA sites that could be sources of potential contamination in a flood? We've analyzed about 100 different population and infrastructure variables, and you can see that analysis for lots of different geographic units. Compare counties in a state, in this case, down to city council districts within an individual city we've got for lots of different cities. Legislative districts, planning districts, a wide range of things. All of it is accessible from our main homepage at sealevel.climatecentral.org. And I would encourage you to come take a look. We continue to produce new research every quarter or so. And I'm happy to help with your sea level questions and reporting needs.